understand if your product line, whatever product you're working on, understand if you're winning or losing every day. And if you understand that, did we win today? Did we get where we needed to be today? If you're winning, great. And then do that every day.
Hello and welcome to the Manufacturing Make Strides podcast, where we explore the world of manufacturing, speaking with experts from across the industry to bring you actionable tips and strategies to help you take strides in your journey. I'm your host Martin, and in today's episode, I'll be talking about the connections between design and manufacturing. Our conversation focuses on how teams can work together more effectively, and what some of the key skills are that can help manufacturing professionals make a lasting impact. I'm excited today to be joined by Craig Higton, who's a seasoned manufacturing professional who spent his career improving processes and bridging that gap between design and production. Today, Craig shares his experiences and insights on how manufacturing teams can work smarter and more collaboratively together to achieve success. I'm excited to get into it, so let's jump straight into it now. Welcome, Craig, to the podcast. You've had an extensive career in manufacturing, but before we get into that, maybe just like to find out a little bit about your background. What was your first job in manufacturing and how did you get into that?
I'm an aerospace systems engineer by degree, but I started out at 16 as an apprentice. I joined the Royal Air Force as an aircraft apprentice. So I spent 3 years training, and then I went out into the big bad Air Force as an aircraft technician, specialising in repair of engines and airframes. So I spent 3 to 4 years doing that, and then I went to university. Gladly, the Air Force paid for me, and I did my aerospace systems engineering degree. And then went back into the Air Force as running really second line repair bays, sort of hydraulic bays, engine repair bays, oxygen bays, anything that could go wrong on the aircraft and needed a bit more detailed repair. We would take it off the aircraft, bring it to one of my factories, we'd repair it and then send it back out. So doing that on numerous different aircrafts, helicopters, that kind of thing. It was a really, really enjoyable time. I was exposed to lean principles, exposed to lots of process improvements, lots of probably not very deep manufacturing, but very deep repair and overhaul techniques. So that's where I started my career, and I did that until I was about 36, and then I joined a consulting company, and I was a process improvement specialist. Many people will understand SAP implementation and what it can do to a business. So I used to go in and prepare businesses for SAP implement or recover them after an SAP implementation. Which was really enjoyable, and that was very eye-opening. And I got involved in manufacturing execution systems then, and implementing manufacturing execution systems, that kind of thing. So really enjoyed that. And then the last 11 years, I was with an aerospace and defence company. Started off in engineering department, so understanding PCB. I was in charge of a PCB design team. Then I was in charge of mechanical engineering design team. Then got into operations and manufacturing supply chain. So I had a broad remit, which was great because I learned about all sorts of more deep engineering entities that really affect manufacturing. So that's why my opinions probably seem a little bit skewed to a deep, manufacturing, a person who's had a deep manufacturing background. Mine's more broad. I don't go as deep in manufacturing, but I'm broader with supply chain quality, continuous improvement, that kind of stuff, and how we can make sure we affect good manufacturing as early as possible. So quite a broad career, really enjoyed it. I'm about to start a new job, so very excited about that. So that's me in a nutshell.
Yeah, that's interesting. Well, the way you started off, you got to see the end result of what understand fully the end result of the manufacturing process and the product in life, throughout its life cycle management of that. Kind of interested to know, what is it about aerospace and aircraft systems that kept you within that? I imagine you must have a bit of a passion for that.
Yeah, you can't see on the camera here, but my office here is there's about 6 different aircraft models around. I love airplanes. I have since a small child, and the technology involved in not only the aircraft, but the systems that you put on an aircraft is incredible. It blows me away every day. I love that kind of stuff. But I'd like to say I'm a bit of a systems thinker. So it's all right having the technology, but if you don't have a good design, a robust supply chain, good processes, then it won't. You're not going to make a lot of money from it, or you're not going to be able to deliver that technology efficiently and effectively. So my passion is the technology around airplanes and the systems that they have. But my real passion is by making the system work so we can deliver value to customers.
Okay, well let's start to dig into that then. So what kind of experiences have you had throughout your career that has given you that passion for systems? And you mentioned before, well, you've kind of intimated a couple of times that some technologies on their own, SAP implementations maybe. If not, I think you were kind of intimating that if they're not planned thoroughly and with thought of integrating it within the business, that can maybe cause some problems.
Yeah, they can. My where I got my passion from is I've had a couple of jobs where I've managed to look at the product development life cycle as a whole system and how we get there, and all the way from a requirement or an idea. I've largely worked in program businesses, so you get a set of requirements from the customer, and then you work as a team. Well, how do we deliver those requirements? And you go through normally a very well staged and organised product development life cycle, big gated process, sometimes between 9 and 15 gates. And what I found is when I was in operations and manufacturing, there was a massive dissatisfaction in manufacturing. And we tended to be blamed for everything. When we couldn't deliver anything on time, or there's a poor quality or supply chain, we'd get the blame. And I was getting pretty fed up with that and saying, well, we get a design, it's generally kicked over the fence. We get to deal with all the issues with the design. Yes, some of our processes aren't super robust, especially when it comes to testing. I grant you that. And also we have to deal with supply chain issues. So I tended to look at manufacturing and say we're getting a kicking here for no reason, and I thought, well, we've got to get more involved earlier in that product development life cycle process. We've got to influence the design, but we've also got to influence which suppliers we use and how good those suppliers are. Otherwise, we'll be left, excuse the phrase, holding the baby again. So we've got to control our destiny better by, first of all, we've got to earn the right to influence the design and supply chain by making sure our manufacturing processes are robust, repeatable, and effective. But then we've really got to try and influence the design of products and programs and the supply chain. So we've got to get in really, really early. And that's where my passion came from, especially with my exposure to PCB design, mechanical engineering design. I knew how to influence those people. So and it was trying to, I've spent years trying to upskill our manufacturing engineers to be able to do that kind of thing, to move left, really influence design and really influence supply chain whilst still keeping an eye on manufacturing processes. So that's where that's my sweet spot, where I spend a lot of my time. And I firmly believe that if you want to deliver the targets, the financial targets that were in the bid, the only way of doing that is influencing that bid via influencing the design, the manufacturing processes, and the supply chain. And if you don't influence all three of them, then you're going to get a less than ideal or lower than your financial expectations will be delivered ultimately.
What's the ideal situation then of that influencing and kind of collaboration across departments? When that works well, how good can that be, basically?
Well, yeah, it can be incredible. When you, especially in the aerospace and defence world, I looked at in one company. I looked at 4,000 programs in a portfolio, and out of those 4,000 programs, only 9 hit the targets that were in the bid. Now, That sounds absolutely incredible. Program managers can't predict the future. They're not fortune tellers. So we do get a lot of variation. And sometimes it's positive, the positive expected completion numbers, and sometimes it's negative. But really, to go in at the bid phase with your manufacturing knowledge and say, okay, then we only need some high level numbers. What demand are we looking at? What kind of delivery schedule are we looking at? What kind of supply chain are we looking at? What do we need? Any capital equipment? It's almost looking at what are we currently capable of, and benchmarking that, and then understanding, well, what do we need to be capable of to win this bid, and then make the financials that we said we would do in the bid. And really, if you can start with that and influencing the price to win on that bid, because sometimes we have to bid lower than what we can do to win the bid, to be competitive. And that's fine. What isn't fine is when you do that and you don't know what you're capable of. You don't know what the delta is or what the gap is between what you're capable of and what you need to be capable of.
So you don't know if it's achievable.
Yeah. So I spent my time putting a numerical value on that, almost designing a production system during the bid phase to say we're going to have to have a touch time build of 10 hours and a lead time, calendar lead time of 10 days. We're going to need 10 of these products in WIP to meet the demand. I did all the maths and did all the calculations for that to say then, well, if you bid it at 50 hours per product, currently we can only build at 80 hours per product. So we need to find 30 hours from somewhere. So either put it in your program risk that we're going to do that, or give me some money now and we'll fix it. And we'll have a look at how do we get down to 50 hours from 80 hours. And doing that during the bid phase, really manages expectations. My experience is that program managers on the whole don't really understand manufacturing and operations super well enough to understand the risks they're carrying. When you look at a program risk register, there's some very generic risks in there, like poor supplier performance, that kind of stuff. I had to sign off bids in my last job from a manufacturing perspective to say, yes, we can do that. So I had to put a numerical value on it. So I think that's really important. If you can do that early on, that can be very beneficial. But yes, very beneficial to do that. But then you've got to go into what I call the next phase. You've influenced the price to win. So we know if there's a gap, we know what that gap is, what that manufacturing capability gap is. Then you've got to go into the what I call the design to cost phase, where we're actually engineering it, designing it, prototyping it. That's where you really need to influence, the design, the engineering developers to say, look, if you change that radii from 1.5 to 1.3, we can use this supplier who's got a better record and do it more cheaply. It's not just the design for manufacturing and assembly elements, which I'm a big advocate of, but it's also looking at what's caused variation in previous incumbent products. What can we do about that? Was a test procedure that was difficult? Was there a vibe or a anechoic chamber problem that we need to address? That was we looked at. So there's many angles you can look at. Also the supply chain, making sure that we select a supply chain and we influence the design so we don't narrow the supply chain. I see that so many times. We need to get our manufacturing engineers and our supply quality engineers involved so that we widen the supply chain and we make it as robust as possible for all elements so that we do have, fallback suppliers should problems arise. Where I've seen very poor designs where the percentage of single source suppliers has been in the high 20-30%. That's covered in risk, that kind of stuff. But this sounds very easy. What I was also finding is influencing engineering designers is very difficult, and it's a skill set that as manufacturing engineers I find a lot of people wanting in that skill set. They didn't have I always said, you've got to have the ability to sit on the end of an engineer's desk and say, look, your design's like this. I need it to be like this. I need you to think about this, 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 and this. And when we've implemented it, and I've implemented it in 3 or 4 different companies, what we found is the manufacturing engineers didn't have the influencing skills, what I call the gravitas, the kind of leadership and influencing skills to sit next to an engineer who's been doing it for 20 to 30 years and say, actually, can we move from this to this? Now, what I found really helped...
But in a way, they'll be open, not say, hey, yeah, do you know you've been doing it wrong for 30 years?
Yeah.
You should do it this way.
That's what you're up against, and that's the human element you're up against. Now, how did we break those barriers down? Well, first of all, we kind of did it in a 2-phased approach. We brought data to it, and engineers responded to data very, very rapidly. If we said, look, your design was like that, and it took us 80 hours to build. If we can change the design like this, we can get it down to 50 hours. I'll give you a great example. We had a product that only took 10 hours of touch labor to build, but it had a 30-day calendar lead time because of extensive testing, vibe, and the biggest element was curing. There was a lot of gluing involved in this product. And so when we looked at it, we went, well, if you've got a 10-hour touch time and a 30-day lead time, that means you're going to have 29 days of product in WIP. And we were delivering 50 of these a day at 5,000 each. So that meant, if you did the maths, every day we had to have £7.5 million worth of WIP on the shop floor, which you had to count, you had to heat, you had to light, you had to look after. If there was any configuration changes, it's painful. And I'm sure all manufacturing engineers understand how painful that can be. So we had to really drive that lead time down. So we looked at the curing and, remember, it's only 10 hours of touch labor. There was 216 hours of curing. And we went back to the engineers and went, look, 216 hours, we need to get that down to 50 hours. How do we do that? And we set them the target. And we explained that if you can get to 50 hours, that takes our working capital down from 7.5 million to 2.5 million. It's not a bottom line saving. However, it can make the program cost positive. And the less WIP you have, the more room you have. You'd have to count less processes, less variability, less risk in engineering changes and configuration changes, that kind of thing. So it's very worthwhile. It's almost teaching I had to teach the manufacturing engineers to put what I call a case for action together.
Yeah. What a business case, basically. Yeah. A business case behind it. Yeah.
And be able to articulate that in a manner that made the engineering designers say, oh yeah, you're right. That looks very painful to us. No one's ever told us that before, and get them to really work together with us. Because the manufacturing engineers, what I find is when we pose a problem and the engineering designers say, oh yeah, that is a problem. Generally, as manufacturing engineers, we know the solutions. We've got a broad remit of, well, we can change this glue. We've got blue light technology to expedite curing. There's all sorts of things that we can do. So, yeah, influencing the design was massive. And I'd say my tip is don't underestimate how difficult that is, because you will have designers who and products that have been making money for years and years and years. And designers would say, why change? Because they don't understand the pain, because manufacturing has been silent for so long. They've put up with it. They've worked around it. It's almost, we call it, you've probably heard this term, the hidden factory, where there's a factory that makes the product, and then there's a hidden factory that deals with all the variation that happens during manufacturing that we don't want. So really, what we're trying to do is get rid of that hidden factory, so we can really, what I call build to plan, so we can just execute it. And I don't take this the wrong way. When we've got a good design, I don't want supplier quality engineers or design engineers anywhere near my shop floor. That's a sign of really good build plan and a really good design, a really good supply chain, is that, you can just click the buttons and away we go on the assembly. But getting to that position, is not easy. So yeah, influencing skills for our manufacturing engineers, a bit of gravitas. I was always saying, let's get them in front of program managers. Let's get them in front of business development people. Let's get them sitting down with engineers. I made my manufacturing engineers sit on earning calls. If your company's listed on an exchange, they do an earnings call every quarter. And I said to my manufacturing engineers, go and listen into the earnings call once every quarter. You'll learn how what you do makes money and what it means to Wall Street or to London Stock Exchange. You'll really start to understand that and understand why we do what we do, why we're trying to influence the design, the processes and the supply chain.
Yeah, because it can be quite disconnected sometimes, can't it? A technical problem in one area of the factory isn't obvious to a lot of people what consequence that's going to have.
Yeah, agreed. And again, as manufacturing engineers, we tend to be, very siloed in our approach. We make sure that a product gets from point A to point C, as quickly as possible without any variation. Whereas, we're very good at fixing things on the fly, making sure every day is a good day. And then, we might have manufacturing review boards where we look at detailed issues, but really we're talking about systemic issues that we're looking at addressing here and putting our hands up and saying, look, this design is really causing us problems, or this supply is really causing us problems. Can we change it? And being more proactive in that, and looking at those three elements, if you get those three elements, all singing together, you can really deliver a fantastic product to the customer and make the money you want to make whilst doing it.
So I think the gist of what you were saying there is to really the ideal situation would be that manufacturing would be able to kind of have influence and to be influencing on a few different levels at the bidding stage and the price to win, at the design stage to make sure it's designed for manufacturer, and in the supply chain decisions to influence the suppliers that are going to be used.
I really don't understand how we can make the money we want to make if we don't have those elements. If we're not influencing those elements for the betterment of the product. So, yeah, and again, it can be the kind of design for manufacturing assembly has been around for many years. If you sit with engineering, they'll tell you, yeah, we do design failure modes and effects analysis and process failure modes and effects analysis. We do design to cost. And when you say, show me, they go, oh, hang on a minute. And what I would advise is you've got to come up with a scoring system to say, I'm here. Okay. And then to make the money we need to get here. And what does here mean? What does that mean? Well, I always used some key metrics like touch time labor, so 10 hours of touch labor. Okay. We need to get to 10. We're at 30. Okay. We know we've got that gap. Manufacturing lead time. We're at 30 days. We need to get down to 5 days. Okay. How do we close that gap? And then you've got your material costs and your labor costs. And then finally, I'd look at yield because that creates a lot of variation. And I'd also, say, right, we're our first pass yield, not a great measure. I prefer rolled throughput yield where you're measuring yield and times it at every operational station or every manufacturing station, and say, right, we're at 80%. How do we get to 100%? And then again, depending on your funding, you might not be able to fix everything, but you've got a target, you've got a current expectation, a case for action, and you've got a target to say that if we can get to this target and give me a budget to get that target, this is where we start making a lot of money, or delivering a product that is exactly what the customer wants. But we've got to recognize we're here and we need to get here and measure it and keep measuring it. You've got a very structured product development life cycle that we measure the technical readiness level of the product all the way through that cycle. Let's measure the manufacturing readiness level of that product as we go through, especially in as I said, touch hours, manufacturing lead time and costs and yield. And then that will drive a behavior that we want.
Mm. So you've mentioned one of these in the conversation up to now, but what do you think some of the key reasons are as to why this doesn't always happen in across all businesses? Why isn't there as much collaboration, and why what do you think the key kind of causes are of designs getting thrown over the fence into manufacturing, and
I think,
you sort it out?
It's a great question, Martin. I think there's a number of variables acting on it. I think one of them is, as I've mentioned, the manufacturing engineering not being empowered to influence the design. I think a lot of it is, especially in the program business, there comes a time where, and I in my last job, I trained the chief exec to stop asking about what the price to win is and start asking, what can we make it for and what can we sell it for? Very different question. Previously it was all about the price to win. Well, yes, we can. You don't want to win bad business that you can't deliver. So there's a bit of that. So what happens is you win a bid and all of a sudden you realise we're 20% out. We've won this bid and now we've got it's yay, we've won the bid. And then,
we've got to make it now. Yes.
Yeah, how do we make it?
Yeah.
And everyone, it's a well known to everyone gets told you've got to sharpen your pencil, everybody. And all of a sudden, all the budget, all the money that you need to influence the design and do all the good stuff and the supply chain, it's all gone. And all of a sudden, the designers are getting, the hours to and we're on the back foot already. We haven't got time, all the money to influence the design, all the supply chain, and we get given what we're given. I think that's probably, I'd say, is the number one variable acting on why companies don't do that. And again, some of in the companies I work for, when you win a bid, it might be 3-4 years before you start manufacturing this. The design cycle could be that long. And a program manager is not going to say, I'm not going to give you £500,000 now to fix manufacturing. That's 4 years away. Everything could change by then. And I think there's a bit of credence in that. I understand that. However, history tells me, and that's where I bring my data, history tells me that our manufacturing, every time we win a bid there, we deliver it up there. We never meet our target. So it's worth, if at a minimum, put it in your risk register and apply some management risk to it. But the best way to attack it is give the manufacturing engineers some budget so they can influence the design and the supply chain. So I think manufacturing engineers have been too quiet and not empowered. And the other thing is they've not, the program managers and the BD have never really understood what's gone on in manufacturing and never given people the budget to influence design. So they've always concentrated on what's the price to win, rather than what can we make it. They don't do the maths early enough to say this is what we can make it for and this is what we can sell it for. That's really key.
Yeah, so having that overview of the more of the aerial overview of the business, of understanding, what the costs will be, and that focus on what the profit will be, which, is what the main focus should be on. There was one thing that you mentioned to me before that stood out in your whole kind of outlook and a lot of the things you've done. It came across to me as very much a proactive kind of attitude, or a very much a proactive approach that you've got and you've had about some of these challenges. And thinking about some of the manufacturing companies I've seen, I know that can be, because issues happen day to day, and it can be quite easy to become very reactive to find the time to, and the quiet to be more proactive can be quite challenging. So I'm just wondering, if that's a challenge you've come across, and how you've managed to keep that future focus and that proactiveness.
Yeah. Well, something probably I shouldn't say on a podcast, but I'm going to say it anyway, is I ask for forgiveness, not permission. Now, I don't recommend that to everybody, but it seemed to work for me. I've always been the kind that would say, well, this makes complete sense to me. And I'd also suggest I've always been very good at working cross-functionally, working in a horizontal manner rather than a vertical manner. So I've always been very comfortable because I've had roles where I've worked in a PMO, I've worked with engineering. I've never done a BD role, but I understand BD because in previous lives I've been a customer. So I understand that, and working, horizontally rather than vertically can always work. But ultimately, you can and this is what I find probably similar to what you're saying, Martin, is I go into factories that aren't doing this, and the manufacturing engineers are almost browbeaten. We've for years we've put up with poor designs, we've put up with poor supply chains. Yes, some of our manufacturing processes aren't great, but we tend to work on them. And the trouble is, what I find as well, so we put up with a lot, but we tend to be amazing in manufacturing. We're amazing firefighters. We've got that skill set where we react really, really quickly and we fix things really, really quickly. So we're very good at managing variation. What we're not so skilled at is being proactive and preventing that variation from happening by moving left, influencing the design. So yeah, we've got it. It's very simple. It's a very simple equation for me. You either put up with the variation that you've got and put up with poor delivery and poor numbers around operation, or you can do something about it. And for me, the case for action writes itself. I reckon I could go into any shop floor, any manufacturing site, and write a case for action to say, give me 3 people, put them in engineering, get them influencing the design, get them influencing the price to win. Let's give them the skill sets. Let's get them exposed to the business, some of the business, more generic business side of how we win work. Get them exposed to that, and they will add more value, than you will believe. And I sincerely think I could write that case for action in 80 to 90% of all manufacturing sites. It's everyone. When you talk to people, it's common sense. Any manufacturing engineer will say, yeah, that's common sense. If you don't get a good design, a good supply chain, the manufacturing process will only take you so far, and we're managing variation from there on in.
So if you're enjoying this episode, please give us a follow on Apple Podcasts or Spotify. That would help us to keep bringing authentic manufacturing conversations with the people who are shaping our industry. Thank you. So you mentioned a couple of things about some of the skill sets that may be missing, or maybe not practiced as much by the manufacturing engineers. So I'd just like to dig into those a little bit more. Yeah. And maybe a follow-up question, or maybe an example of that can be, I can imagine this can be one of the more challenging areas of this process is in the supply chain influencing, because if you were trying to justify that a more expensive supplier should be chosen because that will down the road, maybe 5 years into the future, give us benefits in the manufacturing process. I can see you getting a fair bit of pushback against, purchasing departments who are focused on, maybe lowering their overall costs of supply. So maybe using that as a kind of as a bit of a mini case study, I suppose. What do you think are some of the key are the skill sets that manufacturing folks can work on to influence that?
Yeah, to set the scene for that, I'd suggest that I'll give you a great example here where supply chain and a part of supply chain, there's a team called category managers, and they specialize in certain elements and dealing with supply chain. It might be cables, it might be sheet metal, whatever, and they specialize in that area of supply chain. And on a certain product, the category managers came up with £160,000 saving on this product throughout its life, or for the demand that we had for that product. And it was a real bottom line saving. Everyone went, oh, fantastic. We can put that to the bottom line. We made more money. However, it made the testing yield go from 80% to 30%, made operational touch time go from 15 hours to 20 hours. Again, it's that siloed approach to say, well, we've saved £160,000. Well, what does it mean for touch time? What does it mean for manufacturing lead time? What does it mean for yield, that kind of, you've got to bring that. And that's a skill that is missing in manufacturing engineering as well. The guys have got to be able to crunch data and say, well, what's the impact to my manufacturing processes on cost, quality, delivery and safety? What is the impact by having this supply, by having a more expensive supply? And they've got to be able to, I always call it telling stories. I'd love my manufacturing engineers to be able to tell stories. That's how for me, that's how business gets done. You're able to articulate with numbers where possible a good story that says, it's going to cost £5 a pop more. However, it's going to do this to my touchdown. It's going to do this to my manufacturing lead time. It's going to drive yield up here. And put that data package together and be able to tell that story. And I think that's a skill set that is sadly lacking. I don't think it's difficult to upskill our people to do that, but I don't see that very, very often. I when I go to a shop floor, I always ask, show me your how do you manage that? How do I know if I'm winning or losing today? Show me. And everyone should be able to see that. Am I winning or losing today? And I look for a Gemba board or whatever, safety, quality, cost, delivery. I look for those numbers, but I look for them every day. I went, how do the people know whether they're winning or losing every day? So a lot of the time they're losing. And if you lose, then you've got your demand to deliver, and then you've got your backlog to deliver. And it's just, you'll never recover unless you do something different. So it's giving manufacturing engineers the data and the skills to be able to manage and ensure they are winning every day. But if they're not winning, to give them the tools to influence people to help them win every day. And often the solutions are not in manufacturing. And that's one of the key skills. We've got to get our manufacturing engineers and our manufacturers the ability to influence other functions and say, yes, we won't fix this until we tweak the design by doing X, or we won't fix this until the supplier delivers it in this format, or we get a different supplier, or we try this, or we get the customer to change the requirement on this test because we can't meet that requirement, or we're having to knife and fork it through this test to meet that requirement. So it's the skill set of telling stories around data to build a case for action, to tell the other functions, we're not winning today and we're not winning day on day because of A, B, C, D, and here's the data to prove it. And I think we can get people to that stage, our manufacturers to that stage, where they can tell stories, they can influence the other functions. And then for me, the other key skills that I pick up and I always fall back on is change and change leadership. And looking at that, I use a very standard 7-step process. I always go through it in my brain when I'm doing a transformation or a change. I go, well, have I created an understanding? Do people understand what the issue is? Have we enlisted the right people to try and solve this problem? And have we created a vision of the end state, that we can drive towards? And if you don't have those, and for me, if you don't do those three things well, you're never going to execute very well. So I always go back when I'm looking at black belt projects or any manufacturing change. I always check on those. Did you create an understanding? Have you enlisted the right people? Have you got an end state that you're aiming for? And I always find the majority of programs or transformations that aren't going well, it's due to missing those three elements. Before you get into communicating, the motivating, and then acting, and then consolidating the other 4 steps. If you don't get those first 3 right, create the understanding, enlist the right people, and then create a vision for what good looks like, you're not going to go very far. So influencing, telling stories, and change leadership. If I could wave a magic wand and create a manufacturer with all those, those skills, I think we'd be in a much better position.
Yeah, I think that's really interesting. Yeah, I like your example about the storytelling, because, I can see that some of the data points that maybe engineers and manufacturers do have, like my yield's gone from 80 to 20%. If you go to someone in business or supply chain with the story that my yield's gone from 50 to 20%, that's kind of meaningless really, isn't it? But if you can develop that story and have the overview and tell the business impact story, it's much more meaningful. It means an increase of these number of hours, which means these costs. Yeah, much more compelling.
Yeah, I always call it walking in other people's shoes. We've got to get our manufacturing engineers to walk. What does it mean to the PM? Let's take that example, a yield from 80 to 20. What does that mean to the PM? And put it in the PM's terms. It means your EAC, your estimate of completion, is going to go from, what you predicted, you're going to be 10% off. Have you got the management reserve to cover that? No. Oh, we need to do something about it then, don't we? And being able to then walk into the BD, it means your price to win is way off and you're not going to make the numbers you said you would. So you might not, even if you win the bid, we might not get repeat custom because we can't deliver it to what we bid. And for the engineers, what does it, walking in their shoes, what does it mean for them? It means your design is going to create more hours of testing. You're going to have to go on the shop floor. This always works with design engineers. You're going to have to spend more time on the shop floor, knife and forking this through test, rather than sat in your office innovating and creating the next fantastic product. And if you can, again, understand what motivates people and what makes them want to do something that they don't ordinarily want to do. So yeah, telling that story, putting that case together, really, really, if you've got that skill, it can be really compelling.
I'm going to move now into a couple more kind of shorter questions. What would your kind of first piece of advice be from a manufacturing team looking to make some improvements at the start of next year, use it with their existing resources, and maybe they're looking to become more proactive? What's the first thing you would suggest that they start doing?
I would do 3 things to start with. First of all, I would describe your system numerically in 3 phases. I'd say, what are we budgeted to do? And it might be, we're budgeted to build this product in 10 hours. Okay, that's the budget. What are we currently achieving? Okay, let's go into our manufacturing execution system, factory logics, whatever. Oh, it's taken us 35 hours. So we're budgeted for 10 hours. It's taken us 35 hours. Okay, what's our standard? Our standard should be 5 hours. Okay, so that's why we budgeted 10. We've got, we've got a standard of 5. We budgeted 10, but it's taking 35. You've now got a case for action. I'd always start with that. What does that mean numerically then? So we've got it in touch hours. Okay, what does it mean? What does it look like in lead time, and what does it look like in yield? And then put that in numerical terms to say, well, every product is costing £52,000 at 35 hours when we're budgeted for 30,000, and our standard, what we should be able to achieve, is 20,000. Okay, you've now got a compelling case for action to say we're at 52, we're budgeted for 30, I think we can get to 20. Okay, start building that case for action. And then you dive in to each of your manufacturing steps and say, well, what's driving the hours? What's driving those extra hours? You can't fix everything. You've got the same amount of people, the same amount of time. There might be some really big hitters. What's causing the big impacts? And then it's impact versus effort. And once you've found what's creating those hours, it might be a test procedure, it might be a difficult touch task that's taking too long. It's getting into the root cause of why is that doing that, and looking at an effort versus impact analysis to say, okay, if we fix that, how much effort to fix that, and what is the impact on my hours? And then put a Pareto together and go, okay, we could do these 100 tasks to get down to 20 hours. 5 hours. But actually, if we only do the first 3 activities, that'll take us to below budget. So we're making the money we said we'd make. So let's do those first 3 things. And then I go, okay, to do those 3 things, what do we need to do? And I'd start telling that story, put that story together to say, well, there's only 3 things that we can influence: the design, the manufacturing processes, and the supply chain. What can we do and those 3 things we found? Is it a design issue? Is it a manufacturing process issue? Or is it a supply chain issue? And then work with our colleagues in the other functions to really dive into that and really understand it. But it's all governed by what I find when I go onto product lines and manufacturing teams is they haven't articulated the problem very well. So first of all, if you're trying to solve a problem that you haven't defined very well, you're going to struggle. So don't rush defining the problem. Make it numerical and make it meaningful to all the functions, and then use data to drive it to an end state that you've also articulated in numbers as well. And if you can do that, I think that'd be a great start for the new year to say, look, we're at 35, we need to get to 5. here's the things we've go through those logical steps to say, well, we're not going to get to 5, we're going to get to 10, which is our budget, and we're going to do these 3 things, and we're going to work with designers on these elements, manufacture these process steps, and this is the supply chain problem. And if you've got that case for action, no one's going to say, no, we don't want to get to 10 hours. I'm happy at 35 hours. Nobody is going to say that. If you can tell that story and articulate it in numbers, no one in the business is going to say, nah, I'm not going to give you money to do that. Because you'll say, you give me £10,000 to run this project, I will save you £250,000 over the life of this product. The business case writes itself. So it's giving our staff the skills to do that. So that's the approach I've always taken, and it's generally been fairly successful.
Yeah, I think that's really clear. Yeah, I think that's excellent. I think one of the good things as well that you mentioned, you mentioned that sometimes one of the problems with taking on these activities is not getting clear enough up front with with what the goals or the description of the problem. I think another nice knock-on benefit of getting super clear with your goals and your description of the problem is, or what your target is, when you've reached that goal or when you've gone past that, you can really celebrate your successes, can't you? I think a knock-on effect of not being super clear with your description or the problem is, you're not that clear when you've won, or have you got something to celebrate when you've finished? So having that super clear, I think there's a lot of benefits to that.
And you got to remember, everyone will be striving to hit the standard. A standard is supposed to be difficult to reach, and when you hit your standard, you allow things to settle, and then you redefine your standard and go, okay, we've now hit 5 hours. What's the benefit? Is there any benefit of going to 4 hours? And what's the effort to get to 4 hours? And what's the benefit if we get? And there might not be a business case then. Go, no, let's be happy with 5. That's our standard. Let's maintain that standard, and then let's see what we can do to move people onto other product lines to improve those. Let's learn from this model line we've done, and let's repeat this process on another product line, and then another product line, and it tends to, we start upskilling people. We go through cycles of learning, which is really important. Again, it's something we don't see a lot on the manufacturing. We're so busy managing variation. We've got to get people through cycles of learning. We might train people. When a manufacturer leaves a training, some kind of training, they're not going to be very good at whatever they've learned. They have to go through cycles of learning, and we have to make sure we get those people through cycles of learning and accelerate them through the cycles of learning. Like a DFMEA, we want our manufacturing engineers to be able to run DFMEAs with the engineering designers, but we'll train them, and then we expect the first one they do to be fantastic. It isn't. It will probably need 7 or 8 times to run a DFMEA for them to get good at it. So let's get people through cycles of learning, as quickly as possible.
Okay. Amazing. That's really, really great advice. Thank you. Okay, I'm going to ask you some quick fire, a bit of a mix of different types of questions now. So just be spontaneous is the idea here. It'll be a mix of more fun personal things and work-based stuff. So how would you describe your perfect weekend?
Perfect weekend. A game of tennis. I love tennis. So a game of tennis, a nice meal with the family that I've cooked. I love cooking. A nice glass of red wine and a good film. I'm probably showing my age a little bit there, but a game of tennis, cooking for the family, a nice glass of red wine. That's the perfect weekend. And a bit of warm weather with the sun on your back for a while.
That always helps, doesn't it? Yeah. Yes, that's great. What's the best advice you've ever received?
I think I've already mentioned it on the call, was to sit on earnings calls to understand how you affect the business. And if you listen attentively to the earnings calls, the chief exec is always questioned by very well-educated analysts from all over the country, and listening to his or her answers to those questions is incredible, and you can get insight into where the business is going from there, and you just generally get a good understanding of where the business is at, where the business wants to go, how it's going to get there, how it's viewed by its shareholders. I'd recommend, if you want to, gravitate from, wherever you are, in whatever function you're at, into to understanding the business a lot more. Those earning calls are really well worth listening into.
Is that something you discovered, kind of almost by accident, that you pitched up to one of these and okay, right,
yeah,
okay.
And too late in life as well. The earlier you can start listening on earning calls, and even as a manufacturer, even those really boring emails from the CFO that say these are our finances, have a look at them, try and understand them. You can, as you're looking at them, look at Google. What does return on capital invested mean? What does book to bill mean? And understand that, because you'll get a good picture then of, our book to bill's rising massively, so we're winning loads of work, but our margin is going down. So we're winning work, but we can't deliver it. That's going to tell you a story. Those kind of things that you can then go, something's going to happen that to drive that. We're winning work that we can't execute, and things like that you can pick on. But again, you've got to go through cycles of learning, through sitting through these earning calls and understand the numbers. But I find them very, very useful.
You think it's important to develop that financial literacy, basically?
Yeah, agreed.
Yeah. Okay, what's your favorite part of working in manufacturing? What gets me out of bed from a point of manufacturing is when you train someone and you're trying to get complex ideas across to people, and all of a sudden they get it. It's almost like, I describe it as seeing a light bulb go on above somebody's head, where you've imparted knowledge or experience to them, and they've applied that to their circumstance, and you see a change. That, to me, I could dine out on that every day. I think it's fantastic. You've managed to impart some knowledge or experience, they've applied it, and they've seen a positive result. That, for me, is gets me out of bed every morning to live those moments. Yeah. Okay. Excellent. That sounds really good. If you could solve one challenge in manufacturing today, what would it be?
Testing, making testing work. Especially aerospace, testing is difficult. It's people. It kind of sits in between engineering and manufacturing, and the engineers want to take hold of it and define it from the start, and then manufacturers like to take ownership of it and go, well, we've got to do the testing. How does that work? And it floats. And I'd like to see manufacturers involved in the test strategy. I'd like to see what I call a converging test strategy, where we do a lot of testing at the component level, and then it converges and you do less testing at the sub-assembly, assembly, modular level, and very little testing at the assembled level. And you've got almost that cone of testing going through. But it's something that's, in my experience, it's not very well thought out and not very well executed. And I think it costs the aerospace industry a lot of money. And I think I think if we could get better at testing and how we define testing and carry it out, I think that would be incredible.
Yeah. Okay. We won't dig into much of that here, because I think that's a whole other kind of can of worms, isn't it? But
I agree.
Okay, excellent. If you could master any skill, what would that be?
Ooh, I'd say listening skills. It's a skill that's not well. I don't practice it very well. I'd love to improve my listening skills. I see it in people, sometimes you're deep in conversations and you can see people start wandering around, and sometimes it's, perhaps the way a message is conveyed, perhaps, but I'd love to be able to concentrate and listen attentively for 45 minutes, to an hour. But I get to about 15 minutes. I'm like, I'm overthinking my ability to listen. And sometimes I miss that. What's the crux of the conversation here? So I think it's a skill you have to hone throughout your career. So listening is a very underrated skill, being able to listen attentively.
Yeah, agreed. Okay. Well, thank you for Thank you for all of those. Yeah, really interesting perspective. I'd just like to kind of wrap up before we go. What do you think one action manufacturers can take right now that would set themselves up for future success? I think we've probably covered a lot of things, but yeah, if you would take away one thing.
I'm a firm believer is understand if your product line, whatever product you're working on, understand if you're winning or losing every day. And if you understand that, did we win today? Did we get where we needed to be today? If you're winning, great. And then do that every day. Did we win today or did we lose today? And if you lost, understand why you lost and what are you going to do about it to make up on the next day? Because every day is, in manufacturing is important. But being able to articulate whether you won is the first step, and then numerate it wherever possible, and then doing something about it is the next step. So, I'd say understand if you're winning or losing on a daily basis.
Okay, I'm going to dig into that slightly more then, because you mentioned that before and I thought it was quite interesting, but didn't get back to it at the time. So could we do a quick example of that, and to give us a quick example of what that might look like? And then I'm also wondering, if you're getting started with that, at what level do you put winning or losing? Do you put that just above what's kind of achievable at the moment, or do you make it like a big stretch goal that's difficult? Because I imagine that's a bit of a balance. You don't want to be losing every day, do you? You want it to make it to be achievable, but you don't want to be winning every day.
Yeah, so you've kind of fallen into my trap there, Martin. If you built a plan every day and you've got standard work, the things that drive manufacturing, if you've got a build plan and standard work, you will have a definition of what a good Monday looks like. It might be in your throughput. It might be that to meet the demand by the end of the year, we have to make 10 of these widgets every day. And you go, right, did we make 10 today? No, we made 9. Okay, why did we make 9? Oh, one got stuck in testing. Is it going to, do we understand why? Can we fix it? No, we don't. And it's going to take up the test bed. So tomorrow we're only going to deliver 8. Okay, you've now got a blockage on your test line. Let's understand that. And then, okay, how do we recover? Because on Thursday and Friday, we're going to have to make 11 on Thursday and 12 on Friday. What does that mean? Well, we've set up another workstation, we've got another person, and we should be able to recover. Okay, perfect. It might be yield. It might be, what was our yield today? Our yield was 95%, and we're budgeted for that. Brilliant, we've had a good day. Or our yield was 60%. Okay, what does that mean? And I think at that level, we should keep it in manufacturing language. It's either labor hours, it's throughput, it's yield, it's material availability, it's test hours. But understanding that on a daily basis I've been to too many manufacturers. I'll give you a great example where satellites, I was involved in building satellites, very complex satellites. And we'd gone from building 2 a year to building over 50 a year. So they'd gone from a time of building one every 6 months to building one every 70 hours. And generally the thought around the business was, well, we just go quicker, don't we? And we're like, no, that's a completely different production system. If we could go to a modular design, that would really help. Because when you're building one every 6 months, if something gets stuck on a test bed or a vibe table, you can knife and fork it and fix it. But at 70 hours, building one every 70 hours, if one gets stuck on the test bed, you're never going to recover if it's more than 70 hours. Every 70 hours, there's another one waiting to go on the test bed. So depending on whether it's high volume or low volume, we used to build holographic weapons sites, and we used to build 400 a day, and we'd have a little ticker on a digital readout in the middle of the factory where everyone could see it. And when we hit 400, there's a massive cheer. We'd hit our daily target, and we'd try and overachieve. And if we overachieved, we'd give the manufacturers the Friday off. We don't need to work Friday. We've hit our target because we know what our target is, and we're measuring it every day, and we're trying to, balance, and line balance our product line. So we hit that target. Overachieving isn't good, as underachieving isn't good, but overachieving isn't good because we're making too many for what we need. And it leads to, idle hands. You get idle hands, mistakes start being made. So we've got to go at the tempo. So we're working, effectively and efficiently to hit the demand that we've said we need to do on a daily basis. But it's that daily tempo and understanding, did we hit that? And even if you're only delivering something every 3 years, you should have standard work to say, month 1, day 1, hour 1, we should be here. Month 1, day 2, hour 3, we should be here. That's standard work. I'm a firm believer in standard work and measuring yourself against that standard to understand, are we ahead? Are we behind? What do we do? So it's very different for the volumes that you work at.
Yeah. Okay. Should you be based on that kind of description of the winning or losing? Should you be winning every day, or is that a sign that's something's wrong?
Yeah, you should be. Yeah, you should be meeting that demand every day. Otherwise, it's great that the NHS waiting lists, they've got a set demand that they can hit with the workforce they've got and the hours they've got. They've got a set demand they can hit, but they've got this huge backlog. And they're never going to bring that backlog down without throwing more resources at it. So they're going to be losing it. They can hit their demand every day with the workforce they've got. Yes, you're winning on your demand, but you've got this backlog. So you're not really winning until you've applied enough resource to bring your backlog down at the state rate you said you could bring it down. So yeah, by
so
winning,
if you're winning or losing, criteria has to be tied into the demand, the actual demand that you've got to give a reality.
Because there's no benefit in going faster. We burn people out. Winning is, if you said you're going to do 10 a day, do 10 a day. There's no benefit in doing 12, 13. Set the product line up so we do 10 every day. That's winning. We do what we say we do. And I think that is manufacturing. We want to get to the point where we can do what we say we're going to do. And that nicely ties us back to influencing the design, the supply chain and the processes so we can do what we say we're going to do every day.
Okay, brilliant. Really nice way to wrap up. Thank you for that, Craig. Thanks so much for coming on the show. What's the best way that people can find out a little bit more about you or to get in touch with you?
Yeah, I've got a LinkedIn profile. Find me on LinkedIn. If you want a conversation with me, I'm more than happy to converse with you. My email details are on there, or send me a message via LinkedIn. I'm more than happy to discuss any of the topics or anything about manufacturing engineering at all with you. So yeah, I think via LinkedIn is probably the best way without giving phone details out. But my
probably the safest way. Yes.
Yeah, my email is out there. But as you've probably noticed, I'm quite passionate about it, and I can talk at will about it. So
absolutely.
More than happy to have conversations with people.
Thank you, Craig. Yeah, that was fascinating. Yeah, we'll pop the link to your LinkedIn profile in the description to the episode. So yeah, thank you, Craig. Well, yeah, really all the best for this. Really best wishes for the new job that starts on Monday. That's really sounds like that's going to be a really interesting journey for you again. So yeah, thanks a lot, Craig.
Yeah, thanks, Martin. Appreciate it.
And thank you, everyone in the audience, for tuning in today. If you enjoyed this episode, don't forget to subscribe to us on YouTube or to follow us on Apple Podcasts or Spotify. Thanks again for listening, and we'll see you in the next episode.